All right, Team BC. Here's just a little video guidance to help you tackle these FRQs. So you're ready to bring your A game tomorrow. So let's look at FRQ A first. First thing I want to notice is that the first two FRQs on any AP test are going to be calculator active. So make sure you have your calculator. This question's a lot quicker and easier if you use your calculator. Here we go. A particle moves along the y-axis so that its velocity v at time t greater than or equal to 0 is given by v of t, complicated function. At time t equals 0, the particle is at y equals -1. And then as a quick note, inverse tan is the same as arctan. Okay, let's go to part A. I'm looking for the acceleration of the particle at t equals 2. Well, I know from my physics knowledge that the acceleration is the derivative of velocity. So if I find v prime of 2, that's going to be equal to a of 2, and I just need to find that value. This would be a pretty complicated function to take the derivative of. Luckily, I'm on a calculator active section, so I can use my calculator. In y1, I'm going to type the function y1 minus arctan second e raised to the x. I can just use x here instead of t because it's just an input variable. We're just changing out the variables. So I can hit second quit. Then I'm going to use the derivative. So I need math 8. If you're on one of the blue calculators, this will be a lot easier. If you're on the TI-83, this will be a little bit different. So you need to punch in the function, comma x, that's my variable I'm differentiating with respect to, comma at the point 2. So that's my value, that's my acceleration, -0.133. AP test, you can always round to 3 decimal places. So make sure you have that down. Few students have asked me, do you need to show your work? Because it's calculator active, you can just find a of 2 and write down what it is. Make sure you always label and box your answers, and you'll get that one 100% of the time in the future. Let's look at part B. Is the speed of the particle increasing or decreasing at time t equals 2? Give a reason for your answer. I want to make sure I give a reason for my answer. Is the speed of the particle increasing or decreasing? Well, I remember from earlier in the quarter that speed increasing would mean velocity and acceleration would have the same sign. If speed is decreasing or slowing down, then I know that velocity and acceleration have opposite signs. Well, luckily from part A, I already know what a of 2 is, so that'll be -0.133. And then, luckily using my calculator, I can do y vars, function y1, and I can punch in 2 to get my velocity value. So I get -0.436 equals -0.436. So I see these are both negative, so that means my speed is increasing because they're the same sign. So I can put this in a complete thought to make sure I give a reason. Is the speed of the particle is increasing at t equals 2 because the velocity and acceleration are both negative at t equals 2. Give a reason for my answer. Yes, I did. Is the speed of the particle increasing or decreasing? It's increasing. We stated that here. Get in that question. All right, let's move to part C. Part C, for the time t greater than or equal to 0, at which the particle reaches its highest point. Looks like I dropped the rest of the prompt here. Just a second. On your, it says find the time t greater than 0 at which the prompt reaches the highest point. No typo, never mind. So, reaches its highest point. If I'm talking about an actual point, we're talking about position. If I'm looking for the highest point, if I put those together, I'm looking for the maximum position. Well, if I'm looking for the maximum position, then I know the derivative of position would be changing from positive to negative. Because if I'm looking for a max position, it's going to change from, the position is going to change from increasing to decreasing. So the derivative would be changing from positive to negative. Well, I know the derivative position is v of t, and v of t would be changing from positive to negative. So now I have a strategy for how to solve this. Let's look at a graph of v of t with my calculator. Y equals 1 minus inverse tan e to the x. That's my velocity. I'm going to adjust my window a little bit. I'm going to do 0 to 5 just to start off with 0 to 5. And then let's say this was negative 10 and 10, and I graphed it. It's really hard to see anything right now, so I'm going to try to zoom in like this. So window, let's try negative 2, 2. And so I'm looking for where the velocity changes from positive to negative. I see that happening right around here. So to zone in on that, second calc, use 0, scroll left. Might take a while to scroll. Left, I'm left of the 0, enter. I go right of the 0. I know I'm right of the 0 because I'm at negative y value now. Enter, enter. All right, so I get this number here. So, restate your question because we're going to need to justify in a moment. The particle reaches its highest point at t equals, I'm going to consult my calculator, 0.443 or 0.443 because the velocity equals 0 and changes from positive to negative. So highest point, t equals 0.443, and then your justification, the velocity is 0, and it changes from positive to negative. Quick thing I'd suggest on the test, or the AP test, is sketch what you're looking at. V of t, you know we're looking for this point, you could label that t equals 0.443. There we go. All right, let's go to part D. Part D is pretty tough. Find the position of the particle at t equals 2. Okay, that's the first thing I got to do. Is the particle moving toward the origin or away from the origin at time t equals 2? Well, I know if I found the position, I could find the position first, and then that might help me answer the second part. So I'm just going to focus on this first part here. Find the position of the particle. Find the position of the particle. Well, if I'm looking for position, I know from my physics studies that velocity is the derivative position, so then position would need to be the antiderivative of velocity. So I'm going to need an integral here. Let's think about this. If I had the integral from, say, 0 to 2 of v of t dt, coming from the prompt up here, if I just think about that, that's going to tell me the change in position between 0 and 2. Not necessarily my actual position, just the change in position. Let's label that. Change in position. So the other thing I need to consider is where is my particle starting? This is where it's helpful to go back to the prompt. I see at time t equals 0, the particle is at y equals negative 1. So if I think about that, if I start at y equals negative 1, I change by some amount, then I'll get where I end up. So negative 1 plus this integral will give me the position at 2. This here, just for note, is y of 0. So the initial position plus the change in position tells me my final position. So let's do that with the calculator. That will be negative 1 plus, again, use math 9 to your advantage, math 9, y1, comma x, comma 0, comma 2, and we get negative 0.361 plus negative 0.361. If we substitute that, we simplify that rather, we get negative 1.361. So that's my position, and now I want to think, is it moving toward or away from the origin? Well, this gets me my first point, so let's hold on to that. I know from the prompt that I'm moving along the y-axis, So if I had just a vertical line like this, I'm going to mark off the origin as y equals 0. Well, my position is negative 1.361. So here, negative 1.361 equals y of 2. There we go. And so at this point, here's my particle. So I'm below the origin. And then I know from earlier in the question, my velocity at 2 is negative 0.436. So if I have a negative velocity, I'm going to be moving downward. So now if I put those two things together, I'm moving toward the origin. Well, I'm here, and I'm moving this way, so that's away from the origin. So I'm actually moving away from the origin. So to put that all together, the particle is moving away from the origin because the position is negative and the velocity is negative. There we go. So that completes FRQ A. I'll see you on the next FRQ. If you got stuck on any of that video, take some time, pause, rewind, listen to my explanation a few times. Make sure you got this down. See you in the next video.